this is Chris with Fun Robotics Network here in the pit with 2491 NoMythic. They have one very purple robot, and I'm gonna show it off here.
Hi, my name's Aiden. I'm the design captain on 2491 NoMythic, and here's our robot. So just starting from the ground up, right now we are running Mark IVi SDS swerve modules. We're using a Kraken and a Falcon on them. And we just saw this game and once again saw that this is definitely gonna be a swerve dominant game, and so decided to keep running with it. In terms of our general robot though, at the start of the season, we really said we wanted to do as much as possible. We wanted to play as competitive as possible and play at the highest level. And so when looking at our different archetypes, we had a lot of different options to choose from. But we ended up deciding to go with an archetype that would specialize in placing coral and picking up an algae at the same time. And this really defined a lot of geometries and just systems we were gonna use on the robot. Specifically, when we look at our elevator, we're using a 3-stage elevator, and on that elevator, we're running both an algae end effector and a coral end effector. A choice that we made this season was definitely, we wanted to do both, as we thought doing one end effector that could do both objects will be a little bit too complicated for us with already such a complicated robot. So then going to our coral pass through. So we're also using a funnel to pick up from the human player station. And this funnel is a little bit weird as it has the ability to drop, and this is partly for our climb. But yeah, so it's just one funnel. One thing we wanted to be very intentional with it was that the human player could actually miss by one slot in any direction and it would still land in the robot. And so what that allows us to do is then our human player can be a little bit more confident they're gonna get it in. And so then it goes straight through to the end effector and is now ready to score. We're using a lot of distance sensors on this robot, specifically in the coral end effector, to actually detect once we have that coral. So when you saw it backed out and came back in, that's it automatically lining up. So we don't have to worry about it staying too far back in the elevator and hitting our crossbars and or our funnel. So yeah, there's a lot of automation on this robot, and that's just one example of it. For our climber to deploy, right, and all this packaging of our robot, we actually need to drop our funnel. So once the funnel drops and gets out of the way, then we release our climber. And then it spools out. It's on a worm gear and a very high gear reduction, so it does take a little bit. But once it's out, we then have these little springy hooks. So the cage gets caught in, and then we just pull it back. And yeah.
To get our robot to where it is in this beautiful state, we have some few sponsors that really help us get here. So we have Quality Tool, which makes us a lot of our parts. So any of these cool ones or bent ones right here, they help us do those. We design all of them and send them off to them, and then we get them back looking all cool. And then we send them to Twin Cities Plating, which does all of our anodization. So all the purple and all the black makes us look pretty. We do our stuff, some stuff in-house, like all of our polycarb is us. All of this pocketing, we do ourselves on our X-Carve. So as much as Quality Tool helps us, we do try to do a little in-house.
Hi, my name is Rowan. I'm the lead programmer on NoMythic.
Hi, I'm Zach Smith. I am a programmer on NoMythic and part of the drive team.
This year, our goal with the robot was to do as little of drivers are doing as little work as possible. So we're trying to add lots of automation for accurate lineup with the reef. The drivers never actually manually move the elevator up and down. All those positions are pre-coded, and the elevator will go to those positions once the robot is confident that it is in the right position in front of the reef. It does this through 2 limelights that see April tags and give us robot localization. And we used to use 4 distance sensors on the front of our robot to line us up with the sides of the reef. But we found that on the game elements on the field, the surface of the reef is actually very reflective and is making it difficult for our distance sensors to give accurate readings. So we've been trusting our odometry quite a lot. How the elevator knows which position to go to is a different story.
Hi, I'm already Zach. And we, from the perspective of a driver, we had a very different system of driving this year. Last year was a lot of I assist the driver as a co-driver. This year, we are configuring an entire move every cycle. So I am placing down what we want to do on my controller, and then all our driver has to do is click just a little trigger, and it'll drive there for him. It'll align for him. It'll place for him. It'll back up for him. It'll drop the elevator back down, and he can go on his merry way, which is a huge piece of coding that has allowed us to get faster and faster cycle times this year.
This is Tsunami, and we're very happy we got to show it to you.
Well, thanks for showing off the robot. They got to get to the practice field. This has been Chris. We'll catch you in the future. See you next time.